All right, guys, so composition of functions. The goal of this video is to first and foremost define what a composition of two functions is and do some evaluation using our compositions. So first and foremost, what does it mean to have a composition of two functions? It just simply means that we're going to legitimately take one function and put it into the other one. And that's what I have up here on the screen, kind of showing what's happening in here. You take these values of x, the values of x go through a first function g, they get some output values, and then those output values then all get subbed into a function f, in which in the end what we did was we threw x into g of x into f, to in the end give us f of g of x. And that is where we get our f of g of x. Now what about the domain? Well, the domain of a composition function, in this case f of g of x, is the set of all x in the domain of g, such that g of x is in fact in the domain of f. So we have the domain coming from g. And you're thinking to yourself, all right, well, I find the domain of g, that means that's the domain of f of g of x. Yeah, be careful, all right? It depends if g of x is already in the domain of f. So you got to be a little bit careful with this. We'll do some examples to show where exactly we are coming from. So let's take a look. In the example here, we want to say, hey, here's a function f of x, here's a function g of x, and we want to find two different things. We want to find g of f of x and g of f of negative 2. And when it's all said and done, we want to go ahead and find out what that domain of the composition of g of f of x. So what does this mean? All right, it means that wherever we see an x in g, we are going to substitute the function for f. Let me say that one more time. Wherever we see an x in g, we are going to substitute the entire function f into said x variable. So let's take a look and see what this looks like here. So we have g of x being, so we have g of f of x. So 4 minus, wherever I see an x, I'm going to take the entire f of x function and substitute it on in. And so here we end up getting 4 minus x squared plus 4x plus 4. And I'm going to throw some parentheses around this just so we don't forget to go ahead and distribute all that on over. So we get 4 minus x squared minus 4x minus 4. These 4's are going to cancel on out in the end, and then we're left with negative x squared minus 4x. All right. So where can we continue to go with this specific evaluation? Well, with our evaluation here, we want to find it, we ended up wanting to find on out was what was the evaluation in this case of g of f of negative 2. All right. Well, all this means, guys, is now that we have the composition function, we can just substitute that negative 2 into its composition. All right. Well, let's take a look. Continue to go on through. This becomes a negative 4 plus 8 for a positive 4 when it was all said and done. Now let's take a step back and look at the domain here. Remember, the domain was the set of all x in f such that f is in g. All right. Well, in an example like this, well, the domain of f is all real numbers. So we have negative infinity to infinity. Well, what about for g? Well, once again, we have all real numbers on in there. So the question you ask yourself is f's domain in g? Yes, it is. They're the same thing. They're both negative infinity on to infinity. And so the domain is all real numbers. All right. So there is a kind of an example involving our composition of functions there. Let's continue on. Now what if I said, here is a specific function. And my goal now is to express the function itself as a composition of two other functions that we had. So we substituted one function into another, and it gave us this particular function 1 over quantity x minus 2 squared. So think about it for a sec. I challenge you to pause the video. Think about what the outer function is and what was substituted on into said outer function. Well, in my eyes, what I see here, guys, is I see a big thing, and that is the squared exponent down there at the bottom, because that is a bigger picture, all right? So if I'm saying that h of x is f of g of x, well, what was the f, all right? What was the bigger picture? Well, the bigger picture in this case was going to be the squared term. And so then what was the g of x? Well, the g of x was what you put into the squared term that was different than just x. So that must have been x minus 2. And so we can go ahead and say, hey, h of x is equal to f of g of x, which is the same thing as x minus 2 to the negative second power, or you could have just simply said something like, hey, f of g of x, and gone ahead and separated them out as such. So I'm kind of working backwards here. We got a composition, and do you see what the original bigger and smaller pictures were from it? All right, ladies and gentlemen, it's your turn now. Give this one a shot on your own. We'll go over it first thing. Have a good one. We're on to the next one.